Today we're moving on to our third lesson of this unit, which is verifying inverses. So to verify that two functions are inverses of each other, we just have to prove that when you plug g of x into f of x, or when you plug f of x into g of x, they both give you x. Because if they're inverses, they should be undoing each other, canceling each other out. So let's look at a couple little examples. So for number one, I'm going to have two functions, f of x and g of x, and I'm going to use two different colors so you can see the difference. The first thing I'm going to do is plug g of x inside of f of x. Alright, so this is my first thing. What I'm going to do is plug g of x into f of x. What this means is, inside of f of x is my outside function, 3 minus 2. Instead of having an x here, I'm going to replace x with g of x. So instead of this x, I'm replacing it with this entire function, which is negative 1/2 x minus 3. After this, now I'm just going to simplify. So if I look at negative 2 times negative 1/2, this is 3. Negative times a negative turns into a positive. And what's 2 times 1/2? 2 times 1/2, these cancel out. Right, so it just really leaves you with x minus 3. Now we're trying to combine like terms. 3 and negative 3 also cancel out. This just leaves you with x. So check. This is what we're looking for. We want to make sure that when you plug g of x into f of x, we get x. So far, so good. Our next thing we're going to do is now plug f of x into g of x. So now g of x is on the outside, and I'm going to be plugging f of x into this function. So I have g of x, negative 1/2 on the outside. And here, instead of this x, I'm going to be replacing this x with f of x. Right, so right here, instead of this x, I'm going to replace this x right here with f of x, which is 3 minus 2x. So again, now we're just going to simplify. So you notice that, let's do what's inside the parentheses first. 3 minus 2x minus 3. This is a positive 3 and a negative 3, so they're going to cancel each other out. This leaves you negative 1/2 and then a negative 2x. When you multiply negative 1/2 times negative 2, it turns into a positive. 1/2 times 2 also cancel each other out. It just leaves you with x. Check. Since they both give you x, yes, they are inverses. And we're done. Okay, let's look at problem number 2. So same idea, now we still have two different functions. So f of x and g of x again. So our first step, we're going to plug g of x inside of f of x. Okay, so my outside function here is f of x. So really what I'm doing is I'm rewriting f of x, but instead of x, I'm going to put parentheses. Really. So what I'm doing is I'm replacing these two x's. And inside of those two x's, what I'm going to plug in is my g of x. So this entire function, 1 over x plus 1, goes in both of these. Now to simplify this, what we're doing here is LCD. We want to multiply everything by the LCD to get rid of my fractions within a fraction. So my LCD in this case is just x plus 1. So really what I'm doing is I'm multiplying every single term by x plus 1. Right, so this is being multiplied by x plus 1, this is being multiplied by x plus 1, this is being multiplied by x plus 1. So when I do that, x plus 1, these two cancel out. This just leaves you with 1 plus 1x plus 1. Over here, this in the denominator and numerator also cancels out, just leaves you with 1. And now we simplify. So this is 1 plus, if we distribute this 1, it turns into x plus 1 over 1. Again, we're going to simplify. This is a positive 1 and a positive 1, so when you combine like terms, this gives you x plus 2 over 1. So here, this is as far as we can go. Anything divided by 1 is just itself, so this is x plus 2. Is this equal to x? No, right? This is not just x by itself. Therefore, no, this is not an inverse. If this one doesn't work, then we don't even need to do the second one, because we already know it can't be an inverse. For it to be an inverse, they both have to be x. Cool. Okay, number 3, same idea. We're going to start off with our two functions. So we have f of x, we have g of x, and again I'm going to start off by plugging g of x inside of f of x. So f of x is this function. I'm going to write my whole function, but instead of x's, I'm going to put parentheses. Right, so instead of an x, I'm going to put parentheses minus 5. And then I have 2 parentheses plus 3. So my function f, I'm replacing the x's with parentheses. What I'm going to plug into those parentheses is my red function, g of x. So this entire thing goes inside both of these parentheses. So 3x plus 5 over 1 minus 2x. 3x plus 5 over 1 minus 2x. And again, to simplify this fraction within a fraction, we're going to multiply everything by the LCD. And in this case, the LCD is 1 minus 2x. So what's in the denominator? Everything is going to get multiplied by 1 minus 2x. So all of my terms are going to get multiplied by 1 minus 2x. So this one, this one, this one, and this one. So in this first term, these two cancel out. It just leaves you with 3x plus 5. Over here, nothing cancels out, so we have negative 5, 1 minus 2x. In the denominator, this 1 minus 2x cancels out with what this 1 minus 2x, but we're still left with 2 3x plus 5. Over here, nothing cancels out. We're left with 3, 1 minus 2x. To simplify this, our next step here is to distribute all of my terms. So this leaves me with, I have 3x plus 5. Negative 5 times 1 is minus 5. Negative 5 times negative 2 is positive 10x, because a negative times a negative is a positive. In the bottom I have 6x plus 2 times 5 is 10, plus 3 times 1, and then 3 times negative 2x, which is negative 6x. And now we're just combining like terms. So if we look at our 3x and our 10x, and then our 5 and our negative 5. So 3x plus 10x gives you 13x. 5 and negative 5 cancel out to just give you 0, so we don't have to write that. Same thing in the denominator, so 6x and negative 6x. Those two are going to cancel out and give you 0, but you still have a 10 plus 3, which is 13. Look what happens here. The 13s cancel each other out, and this just leaves you with x. Check. This one works out. So now we have to do the opposite, where we're plugging f of x inside of g of x. So this time we're starting off with g of x, the red function, and this is my outside function. So I have 3, and every time I see an x, I'm replacing it with parentheses. So 3 parentheses plus 5 over 1 minus 2 parentheses. And every time I see parentheses, I'm going to be replacing it with now f of x. So I'm plugging this one in to my parentheses. Both of them. Okay, same step as before, where we're now going to be multiplying everything by the LCD, which in this case is 2x plus 3. So I'm multiplying 2x plus 3, 2x plus 3, 2x plus 3, 2x plus 3. So on my first term, I have 2x plus 3. These two cancel out, leaves you with 3x minus 5 plus 5, 2x plus 3, over 1, 2x plus 3. And then these cancel out to give you minus 2x minus 5. And now we are just distributing all of these. So when we distribute, this gives us 3x minus 15 plus 10x plus 15. In the denominator, we have 2x plus 3, negative 2x plus 10. So be careful, negative times negative is a positive. And now again, we're combining our like terms. So we have 3x and 10x. Those two add together to give us 13x. Negative 15 and positive 15 cancel out. Over here, our 2x and our negative 2x also cancel out. And so we have 3 plus 10, which is 13. Again, 13x divided by 13 just gives you x. So check. Both of these give you x by itself, which means that yes, they are indeed inverses.